Hi, today we're going to talk about conserving mass in a chemical equation. But before we do, I'm going to talk about certain parts of a chemical equation. We start with the reactants, and we end with the products. I know this is a review, hopefully. And whatever charge we have in the reactants, we have to have that charge in the products. Whatever mass we have in the reactants, we have to have that mass in the products. Whatever energy we have in the reactants, we have to have that energy in the products. So, everything is conserved in a chemical reaction. Mass, energy, and charge. The law of conservation of mass states that whatever you start with, the mass that you start with, you're going to end with that mass. So using an example, if I had A and B, and I'm going to be left with C. Let's just say I had 85 grams of C, and I had 5 grams of A. What is my mass of B? Well, this is as simple as a algebraic equation. 5 plus x equals 85. Again, 5 plus x equals 85. I don't think I really have to explain this because you should know that x equals 80 grams. This shows the law of conservation of mass. The law of conservation of mass, just to review, it says that matter is neither created nor destroyed. You can't have more atoms at the end than you started with. You can't have more atoms at the beginning than you ended with. The number of atoms has to be equal on both sides. All right, we're going to look at an example of how to figure out the quantity of every atom that is present in a compound. Now, when I have a number in front, because of the law of conservation of mass, you're going to have to put numbers in front of a compound. And if you put a number in front, this number refers to everything behind it. So everything back here is multiplied by 2. Now when you see a number like this, everything immediately in front of it is multiplied by 3. So I'm just going to write times 3. Right here, it is multiplied by 2. In this example, we're going to have 3 calciums, and this example, we're going to have 2 phosphates. But we're going to multiply everything by 2. So I'm going to have calcium, there's going to be 6, phosphorus, there's going to be 2, but we have another 2, so there's going to be 4. And oxygen, so there's 4 oxygens normally, but then you multiply it by 2, there's 8. But then we also have this 2 in front, so the oxygen is actually going to be 16. You need to pay attention to how this number works. If you mess up with this, if you mess this number, it affects everything behind it. So pay attention to that. Now what I want you to do right now is look at the practice problems.